All right, so here's 5.4, exponential growth and exponential decay. So something that's growing or something that is decreasing, that's what we are going to be looking for here. And this whole unit is about exponents. Now, the general form of exponential growth and decay is this y equals a times b to an x value. This b term right here is our exponential term, is the value that has an exponent. This a term right here is a number that is a multiplier, okay? So this number over here can be any value, okay? And it can be positive, it can be negative, but this is usually our initial amount. Okay? Anything that's growing, it has some sort of initial amount, or decaying, it has initial amount. This guy over here, this b value, is our rate, is our growth factor or our decay factor. Something is decreasing by a certain rate or something is growing by a certain rate. And this is the exponent. Usually we are referring to time. Okay? Usually it's referring to time whenever we're dealing with exponential growth or decay. So these are the things to be looking for whenever I read a word problem. I'm looking for a time information, I'm looking for a rate information, and I'm looking for initial amount information. This formula will be given to you. You just have to understand what the word problem is trying to refer to. Now, this rate is very important. If this is the formula for growth and is the same formula for decay, how do I tell the difference? The difference is the rate of where things are growing or decaying. If the value of b, and I'm going to write this down over here, if the value of b, if b is greater than 1, we are dealing with growth. Okay, it's a growth factor. But if b is less than 1, but not 0, of course, it cannot be 0. If b is less than 1 and b cannot be 0. So if b is less than 1, and I'm referring to fractions, so b is between not 0 and 1. Fractions like 1/3, 1/4, anything between 0, not including 0, and 1. Then we're dealing with decay. Okay? Something that is, I started with a certain amount and then I am reducing by half. Then I am getting less, I'm decreasing. Okay? So that is a rule that we need to try to remember. If the formula is given to you, this is what I want you to remember. If something is growing, the rate is going to be greater than 1. If something is decaying, the rate is going to be a fraction, but definitely not 0. It does not make sense for b to be 0, and I'll explain to you why. If b is 0, 0 to any power is going to be 0, and then when you multiply by this initial amount, you're going to have 0. So this whole thing is going to become 0 if b is 0. So it does not make sense for b to be 0. Okay? b is going to be a value between 0 and 1, not including 0, or greater than 1. All right. Now let's see some examples to try to make sense of it. The nice thing about the worksheets, guys, is that we give a lot of explanation before we ask you to do something. And if you pay close attention and if you read it closely, let me zoom in a little bit more. If you read it closely, it says identifying the initial amount a and the growth factor b in each of the exponential functions. And then we give a hint. It says in the exponential equation, y equals the value of a times b to the x power. A is the initial amount, so we want you to be able to identify the initial amount and then find out the b, which is the growth factor, and it has to be greater than 1. If it is not greater than 1, then it's not a growth. It will be a decay. So take a look at the very first value. The very first function, I have 2 times 3 to the x power. Well, this guy over here is my initial amount. So a equals 2, and my term that has the x value is my base, b, and since 3 is greater than 1, b is 3, and 3 is greater than 1, therefore is a growth. Okay? Growth. Just practice that. Even though it's not asking to tell if it's growth or decay, practice remembering that over and over. It's just a good practice to have it before you go into the test. Okay? Now take a look at number 3. Number 3, I have another function, and it equals 6 to the t term. So I don't see an a value, okay? I don't see an a value. I just see something to the t exponent. So anytime we don't see an a value, you may assume that a equals 1. And mathematically, it makes sense. It is an invisible 1 in front of the 6, and it doesn't change anything. I can write gt equals 1 times 6 to the t, and you can see 1 times 6 to the t will still be 6 to the t. Okay? So a is 1, and b is 6. And 6 is greater than 1. 6 is greater than 1, so this is also a growth case. Okay? Now, I would like to do number 2 and 4, so you can practice identifying the a value and the b value. This number 3 was the hardest one because the students don't realize that a equals 1. Okay? Sometimes they say, oh, there is no a, so a equals 0. That is not correct. If a was 0, then 0 times 6 would be 0. Okay? That's not true. Now it says, use the given function to find the balance in each account after the given period. And we have the equation given to us already, okay? 3,000 is the principal, 3,000 principal, earning 4% compound annually after 6 years. So here's my initial amount of 3,000, okay? That's my a value. And I'm getting 4% compound interest. I'm earning 4%. Here's my rate, and here is my 6 years. It is my x exponent. And they already put it all together for you. Now the students have a hard time, a very difficult time with this 4%. And let me show it to you something very important. Okay, there's not room here, but I am going to explain it right here. Y equals a times b to the x. That's what we're dealing with here. Y equals, my initial amount is $3,000. $3,000. I'm going to put in parentheses my b value. It says 4%. 4%. But we cannot write 4% here. We have to write 4% in decimals. So 4% is the same thing if you divide 4 divided by 100. That's exactly what 4% is. So the students quickly learned that all you have to do is grab the 4, move it 2 decimal values over, and 4% becomes 0.04. But whenever you are investing, they apply that 4% to the total amount that you have. So you get the 1, which is the total amount that you have, plus 0.04, which is your rate that you're actually going to be getting every year. Okay, so you're going to get what you started with, which is your 100% of your money, plus 4%. So the rate of change is actually what you started with, 100% of your money, plus your 0.4 to the how many years you want to live there, which is 6 years. All right. So that's why this became my money, 100% of my money, plus the 0.04. I wrote it wrong here, 0.04. Okay. So we get 100% of the money we started with, plus 4% of what we had. That's why it becomes 1.04. Okay. Now they're asking you to just find out how much money you would have at that time, 6 years. And I taught you guys in the calculator how to do that. I strongly suggest you get yourself a calculator and get used to working with that calculator, okay? So if I calculate this in my calculator, I would do 1.04, okay? I don't know if it shows it well on my calculator there. 1.04, and then I use this little button here, y to the x power, so I can take it to the exponent of 6, push enter. And it gives you this ugly number, and then you have to multiply it times 3,000. That equals 3,793, equals 3,795.95 ... forever. We're most likely going to ask you to round to the nearest whole number, okay? If it was to round to the nearest whole number, the 9 would make the 5 a 6. So it would be $3,796. That's what you would have after 6 years. Not that much money, but I want you to understand why we have that 1.04 from the 4%. So now here's another case, very similar, and I'm going to explain it again. Y equals my initial amount, which is $2,000. That's what I'm going to deposit in the bank. That's going to be my principal amount. And I'm earning 6.8%. So 6.8%. So I taught the students move the decimal place 2 decimal places over, so it becomes a decimal value. So 0.068. But I am going to get that plus 100% of my money, okay? 1. Okay? I'm going to get my money that I started plus 0.068. And that's why this becomes 1.068, and they want to know after 3 years. Okay? So the equation is given. I want to explain to you why it's given that way. Now do it in your calculator. 1.068 to the third power. So let's do it together here. 1.068. Then I type this value, this function right here, y to the x. Okay, I push this y to the x. It doesn't seem like anything changed, but then I can do it to the third power and then push the equal button. And then times it by the 2,000, which was my initial amount. And that equals $2,436. $2,436. Let's keep it to the nearest whole number. And there we go. Okay? So that is an explanation how to deal with exponential functions. With growth, we're growing money, we're investing, we're making it more, so you should get everything that you put in first plus the percentage that they're going to give you of your whole money. Okay? So hopefully, these next two problems over here, you should be able to understand based on these two problems right here, 5 and 6, and be able to create your own. Okay? I don't want to do it for you, I want you to try it. And then it says, identifying the initial amount A, and now is the decay factor, the B in each exponential function. Now they give you the hint. They say in exponential equations, y equals A times B to the x, A is the initial amount, and B is the decay factor if B is less than 1. Okay? But B cannot be 0. B is not going to be 0, or is not even an exponential function. But it's going to be a fraction, okay? It's going to be 0.01, 0.02, 0.25. It will be a decimal value, okay? So here, A equals 4. There it is my initial amount. It's multiplying. And B is my 0.2. That is my decay rate. Something is decaying by 0.2. And you can do the same thing for number 10. And then here, they want you to actually tell the difference. Now it's mixed. Can you tell which one is growth and which one is decay? Okay, hopefully you can tell the difference. And then here on the other page, they already give you the equation. Okay, they already give you the equation. You read this word problem right here. They want to know how much revenue will the town have available 10 years from the date that the town managers report. If the equation has the models, the growth is this right here. So they're giving you this right here. You're switching the x value for a 10. Okay? So you would have f of 10 years equals your 2 million, 1, 2, 3, 1, 2, 3, and 1.04 to the 10th power. Do that in your calculator and you should get your answer. Okay? And it's going to be the same thing here. They give you the equation and they ask you how many bass will live in the lake after 4 years. I told you the exponent always has to do with some sort of a time. So replace your x with a 4, type in your calculator, and figure out what the value is. So this worksheet is very calculator based, all right? So hopefully this helped understand between growth, you always have that 1 plus, and then decay, that it is a value less than 1. Okay, so practice that and come to Math Lab and ask for help. Thank you.